Here we are solving October 2021 Pure Math 4 paper. In part 1 of this video we covered question number 1 to 4. Let's look at question number 5. There is a figure given and the parametric equations of the curve is also given. Use parametric differentiation to find the gradient of the curve at x is equal to 3. So you need to differentiate them separately, dx with respect to t. When you differentiate this, 5 becomes 0, 2 tan t becomes secant square t. And then when you differentiate y with respect to t, you need to apply chain rule. So take it as 8, keep 8 as it is, secant square t, take it as secant t whole square. It looks like x square, so derivative of x square is 2x times differentiate secant x, you will get secant x tan x. That's a chain rule. So it's basically 16 secant square t tan t. Now let's find dy over dx, which is same as dy over dt. You divide them by dx by dt. dy over dt is this 16 secant square t tan t divided by 2 secant square t. Secant square can be cancelled, you will get 8 tan t. But we need the value when x is equal to 3. So when you sub in x is equal to 3 here, you will get 3 is equal to 5 plus 2 tan t. Make tan t as a subject. 3 minus 5 is minus 2 divided by 2. Tan t is equal to minus 1. Sub in here, you will get the answer. 8 times minus 1. So you will get minus 8. That's the answer for part A. Let's move on to part B. Find the Cartesian equation. We need to combine them and find the Cartesian equation in this form. Okay. The first parametric equation is x is equal to 5 plus 2 tan t. I'm going to make tan t as a subject. So it's going to be x minus 5 divided by 2. And the second parametric equation is 8 secant square t. So y is equal to 8 secant square t. So y over 8 is going to be secant square t. There is this identity, secant square minus tan square is equal to 1. Secant square is y over 8 minus tan square is the square of this. 2 square is 4 is equal to 1. Make y as a subject. Multiply through it by 8, you will get y is equal to, when you multiply this by 8, it becomes 2. Goes to the other side, 1 plus 2 times x minus 5 whole square. Or we'll write it in this form, 2 times x minus plus whole square plus 1, because it looks exactly like this, where a is 2, b is minus 5, c is 1. So it's not going to be 1. When you multiply by 8, it's going to be 8. That's all. Now the next part, find the range of f. The graph is given here. It's a quadratic graph. We have got the Cartesian equation of the graph, 2 times x minus 5 whole square plus 8. So usually when you want to find the range of a quadratic graph, you need to know the turning point, because the range of this function is basically the y values from here to here, right? So the turning point from here, you can write the turning point as 5, 8. That's the turning point. So definitely this value is 8. Now we need to find this value. So that's the range, right? That's when we are going to use the values of t. We are going to take this x and the values of t. X is equal to 5 plus 2 tan t. The domain of the parametric equations is given as minus pi over 3 is less than or equal to t is less than or equal to pi over 4. That means basically these two x values, these are all the x values, x1 and x2. The corresponding extreme values of t are given. So to find the x coordinate of this point, if you can find the x coordinate, you can find the y coordinate, right? You sub in this value in here, minus pi over 3. So in radian mode, you write 5 plus 2 tan negative pi over 3. I think I forgot to change it to radian mode. 5 minus 2 root 3. X is equal to 5 minus 2 root 3, and we know the equation of the function, the function representing the graph, 2 times x minus 5 whole square plus 8. Sub in the x coordinate here. So it's going to be x is 5 minus 2 root 3. When you subtract 5, it becomes minus 2 root 3, and square it, you get 12 times 2 plus 8. You get 32. So that's the y coordinate of this point. Therefore, the range is 8 is less than or equal to f of x or y less than or equal to 32. That's the range of this function. Let's move on to the next question. Question number 6. We have a figure given, figure 2. And the question says, figure 2 shows a sketch of the curve with the equation y is equal to this from x is equal to 0 to pi over 2. As you can see, x is 0, x is pi over 2. The region R shown shaded in the figure bounded by the curve x-axis and the line with the equation x equals pi over 6. Using the substitution, show that the area can be written in this form. So to find the area, we need to integrate the y from pi over 6 to pi over 2. Pi over 6 to pi over 2. So it's same as integral pi over 6 to pi over 2. Replace y by the function 16 sine 2x divided by 3 plus 4 sine x whole square dx. In this integral, we need to replace u by this, use the u substitution method, and get the answer in this form. That's what we are going to do now. Okay, I'm going to slowly convert everything in terms of u first. This thing is u, so we can write it as u square. On top we have 16 sine 2x. 16 sine 2x. Replace sine 2x by 2 sine x cos x. So 16 sine 2x becomes 16 times 2, 32 sine x cos x. I am using the double angle formula for sine 2x. So from here I can write u minus 3 is equal to 4 sine x. If I have 4 sine x, I can replace it with u minus 3. So what I'm going to do, I'm going to put integral. The numerator is supposed to be 32 sine x cos x. I'm going to write 32 as 8 4s are 32. 8 times 4 sine x times cos x times dx. Why I split the 32 into 8 times 4? So that I can replace 4 sine x by u minus 3. And one more thing, when I differentiate this, du over dx is equal to 4 cos x. In other words, I can write cos x dx as du over 4. So what I'm going to do, I'm going to replace this 8 times u sine x as 4 sine x as u minus 3 divided by u square. Cos x dx is du over 4. That's all. I have converted everything in terms of u already except the limits. Now I'm going to convert the limits also in terms of u, like the limits for u. So the values of x are pi over 6, pi over 2. U is 3 plus 4 sine x. So find the limits of u now. 3 plus 4 sine pi over 6. That's 5. That's a lower limit. Upper limit now. Sine pi over 2. Sine pi over 2 is 1. You will get 7. So upper limit is 7. Now we need to integrate this. I can cancel this. I'll get 2. So all I have is 5 to 7. 2u minus 3 divided by u squared du. Split the terms. I can write it as, I can keep 2 outside. Integral 5 to 7 u by u square minus 3 by u square du, which is same as 5 to 7. U by u square is 1 over u minus 3 u power minus 2 d. Now integrate it. You will get ln u minus, this becomes u power minus 1 by minus 1. So it's becomes plus 3 by u. The limit is 5 to 7. We need to write the answer in this form, a plus ln b, a single logarithm. So when you sub in the upper limit, it's going to be ln 7 plus 3 over 7 minus lower limit ln 5 plus 3 over 5. There is a 2 outside. So it's going to be 2 ln 5 minus ln 7 is ln 7 over 5. 3 over 7 minus 3 over 5. 3 over 7 minus 3 over 5. You get minus 6 over 35. Minus 6 over 35. Need to multiply throughout by 2. So 2 ln, but you can put the 2 as a power. Probably I'll write one more step. Minus 12 over 35. Sorry, ln 7 over 5, right? Not 35. You can put this 2 as a power using laws of logarithm. So it becomes ln 7 over 5 whole square is 49 over 25. So the answer is minus 12 over 35 plus ln 49 over 25. Why we are writing this way? Because they want the answer in this form, a ln b. That's all. Question number 7 now. With respect to a fixed origin O, the line L has the equation this. Point A has position vector 9i minus 3j plus 2k. X is the point on L nearest to A. What does that mean? Let's say you have a straight line L here and a point A here. You need to consider a point that lies on this straight line L. The point can be here, here, here. The point can be anywhere. But the point is nearest to A. What does that mean? If let's say the point is here, if you draw a line from the point to A, that line should be perpendicular. So that's the point they are talking about, because that's the point that would be nearest to A. So we are going to consider the point X here. So what would be the coordinates of X? OX is equal to, using this, usually you need the value associated with the point, but it's not value of lambda associated with the point, it's not given. So just write in terms of lambda. You'll get 4 minus 4 lambda, 2 minus 3 lambda, minus 3 plus 5 lambda. That's the position vector of X. But you write this, that's not the one you to find here. They want you to find the actual coordinates actually, not in terms of lambda. So that's when we use this condition. The AX vector is perpendicular to the line. If two vectors are perpendicular, the scalar product or the dot product of these two vectors are 0. So first what we need to do, we need to find AX vector. Use the formula OX vector minus OA vector. We just found the OX vector, which is 4 minus 4 lambda, 2 minus 3 lambda, minus 3 plus 5 lambda, that's OX vector. And then take OA vector. 9 minus 3 plus 2 minus 9 minus 3 plus 2. You will get the AX vector. It's going to be 5 minus 9 is minus 5 minus 4 lambda. 2 plus 3 is 5 minus 3 lambda. Minus 3 minus 2 is minus 5 plus 5 lambda. That's AX vector. Now since the AX vector is perpendicular to the straight line, take the AX vector 5 minus 3 lambda minus 5 plus 5 lambda dot product of the direction vector of the straight line. The direction vector of the straight line is this: minus 4 minus 3 5. Minus 4 minus 3 5 is going to be 0. If two vectors are perpendicular, the dot product is going to be 0. Using that, you can find the value of lambda. Once you know the value of lambda, you can get the coordinates of x. So you need to multiply the corresponding one. Take this and multiply the first one. You will get 20 plus 16 lambda. Take the second one and multiply this. You'll get minus 15 plus 9 lambda. Take this and multiply this. Minus 25 plus 25 lambda is equal to 0. So when you simplify this, you'll get 25 plus 25, 50 lambda. And then this is 40. 20 minus 40 is minus 20 is equal to 0. Lambda is equal to 20 over 50, which is 2 over 5. Now using this value of lambda, you can find the coordinate of x. You just need to sub in here. So this is OX in terms of lambda. Now we got the lambda as 2 over 5, subbing here. 4 minus 4 times 2 over 5 is 8 over 5. So it's 12 over 5. You can write it as a point because they want the coordinates of x. So don't write it in the vector form. 12 over 5. 2 minus 3 times lambda, which is 6 over 5, is 4 over 5. That's the y coordinate. Minus 3 plus 5 times 2. Minus 3 plus 2 actually, which is negative 1 is the z coordinate. That's the point x. So we answered this already. The coordinates of x. Now they want you to find the shortest distance from A to L, which is this length. So we need to find the AX vector and the modulus of AX vector. We have AX vector here. This is AX vector. Sub in the lambda value there. So this is AX vector in terms of lambda. Now replace lambda by 2 over 5 now. 2 over 5. And then find the modulus of this vector. So minus 5 minus 4 times 2 over 5 is 8 over 5. It's negative 33 over 5. Negative 33 over 5. And then 5 minus 3 times 2 over 5 is 6 over 5. Is 19 over 5, and then minus 5 plus 2 is negative 3. That's AX vector. So we need to find the shortest distance from A to shortest distance from A to the line is this, the length of AX. To find that, you need to find the modulus of AX vector. So modulus of AX vector is equal to square root of 33 over 5 or negative 33 over 5 square, 19 over 5 square, minus 3 whole square, or just simply 3 square. Square root of 33 over 5 square plus 19 over 5 square plus 3 square 9. You get square root of 67. Do we need to change it to decimal? Let's go back and read the question. They want the answer in this form. D is an integer. So we solved this already. Now part B of the question says the point B is the image of A after reflection in L. So let's say this is a straight line L. A is here. This is point X. So B should be somewhere here. So basically we can write AX vector is equal to XB vector, or you can write XB vector as OB minus OX vector. So we are going to sub in AX and OX here. We got AX vector here. It is minus 33 by 5, 19 by 5. Minus 33 over 5, 19 over 5 minus 3. Is that minus 3? Yes. Is equal to XB vector is OB vector minus OX vector. We got OX vector also here. 12 over 5, 4 over 5, negative 1. 12 over 5, 4 over 5, negative 1. Now if you can bring this vector here and add them, you will get OB vector already. So OB vector is equal to, when you add these two, minus 33 plus 12 is 21 over 5 minus 21 over 5i. You add these two, you will get 23 over 5j. Minus 3 minus 1 is minus 4k. So that's the position vector of B. That's all.